A skin-like breakthrough in electronics. Imagine electronic devices that can repair themselves just like human skin. Scientists at the Technical University of Denmark, DTU, have created a revolutionary material that brings this idea closer to reality. The new electronic material is flexible, tough, and capable of healing itself in seconds, traits that could transform the fields of healthcare, robotics, and wearable technology. Traditional electronic materials are rigid and fragile, often unable to withstand damage or adapt to changing environments. The DTU team tackled this challenge by blending graphene, a remarkably strong, electrically conductive carbon material, with PETIT, PSS, a transparent, conductive polymer commonly used in flexible electronics. The result is a composite material that's not only soft and stretchable but also self-repairing, multifunctional and human-like. Our goal was to create a scalable, adaptable platform that integrates softness, flexibility, and self-healing into one system, says Associate Professor Alireza Dawlatshahipiruz of DTU Health Tech, lead author of a study published in Advanced Science. The new material mimics the sensory and healing properties of human skin. It can stretch up to 6 times its original length without losing integrity and quickly recovers from damage. These qualities make it ideal for wearable medical devices, soft robotics, and other applications that require responsive, body-compatible materials, from spacesuits to smart bandages. Beyond its physical resilience, the material can regulate heat and detect environmental changes such as pressure, temperature, and pH levels, making it well-suited for continuous health monitoring. The self-healing and sensing abilities of this material open up possibilities in various fields, Dawlatshahipiruz explains. We're envisioning uses from advanced spacesuits to smart bandages that track wound healing, or prosthetics that feel more natural and respond to the body. Next steps toward real-world use. DTU's researchers are now working to scale up production of the material and test it in real-world applications. With its unique blend of flexibility, strength, and responsiveness, this skin-inspired innovation could soon be integrated into next-generation medical technologies, soft robotics, and beyond.